VLANs or virtual local area networks. VLANs have been around since about the 1990s, and they were a bit of a lifesaver for the networking industry, because before they were used, any networks had to be separated on a different host or switch in most cases, and that would be a physical separation, so they would just be set up on different networks. But what a VLAN allows you to do is it will provide you logical separation, so you can set up multiple networks or LANs on the same switch, but still keep that traffic separate. So it will mimic basically what you would do with a physical switch, just on that same switch. So why would you set up a VLAN? So VLANs provide a number of advantages. I'm just going to read through these very quickly. So the ease of administration, very easy to set up once you know how, which Craig's going to talk through today. Confining broadcast domains, so keeping the information separate from department to department is one of the major advantages of setting one up. The main one, the one that most people will talk about as an advantage, is the reduced broadcast traffic. I won't talk too much about that because obviously that's a large part of what Craig's going to be talking about when he goes through the more technical stuff. Enforcing security policies, which is another feature of keeping departments separate from each other. So keeping your HR department with all of their employee details separate from your marketing department, who have got all of the customer details and the email lists and all that kind of stuff, is incredibly important, especially under GDPR rules, which really press that home. You can also look forward to high performance and reduced latency, and again, just really hammering home the security aspect. You know that your HR team can work on sensitive information and it won't be seen by any other teams because there's no link between the networks there. Okay. So now moving into the VLANs, Craig's going to talk through the normal network setup and the three layers of, is it network topology, Craig? Have I got the right term there?
That's right, yeah. So we're going to have a little chat about network topology and what it means and how we can implement VLANs. Before we start implementing VLANs, it's a good idea just to get an idea of how the communication needs to run between switches, and that's what we're really going to have a look at first. Do you want to run the slides through, Alan, and then I'll just chat as we go?
I'm pressing the button.
There we go. Okay, so if you was in last week's webinar or 2 weeks ago, you would have seen that this diagram before, where we talked about our core switch, distribution, and edge. So I just want to get those on the screen so we can have a look. So the core switch needs to be understanding all the VLANs that you're going to have on the network. There's two ways of doing it. You implement them on the core, and that means the whole network has the ability to get right down to the edge of different types of VLANs and different segmentations. Or you can do things at the edge and keep it private. So you might have heard about private VLANs and things like that. What private VLANs means is you can use a switch to change how information is broken up at the edge. So let's say, for example, we look at that switch on the edge on the left-hand side, where we have two PCs that are connected to it. Now, what we could potentially do is have one of those PCs on a separate VLAN, another one of those PCs on a different VLAN. Now, the rest of the network doesn't necessarily have to know about the VLANs on that switch. That's what we call a private VLAN. Now, if we take the alternative of that, where the core switch has all the VLANs and then it filters down and you can break things off. So let's say, for example, we look at a distribution on the left. Let's say we have 4 VLANs on the left switch and 4 VLANs on that right-hand switch at the distribution level. That means anything on the left-hand side will have 4 that it can communicate with going back to the core, and we can start breaking down. So by the time we get to our edge, maybe our edge could be used for maybe 3 or 4 different VLANs, or maybe just 2 VLANs. So 2 VLANs on one switch, 2 VLANs on the other switch. And then on the right-hand side, you can do the same again. So what's important to know is that the communication flow has to be there set up correctly on the switch in order for it to be able to use the VLANs. So if you have multiple VLANs at the bottom switch and you try and get that communication going back to your core, the core switches and the distribution switches have to be aware of those memberships. That's what we call a VLAN membership. So just to give you an idea of how you would set them up from an IP perspective. So when you buy a D-Link switch, you'll have a default VLAN. It's VLAN 1. What that means is it's an untagged network. So VLAN 1 is always untagged because it uses a VLAN ID of 0 and 1, and 0 and 1 is always untagged. VLAN tagging starts at VLAN 2 and up, and it goes up to over 4,000 VLANs that you can use. So what we want to do really is set up our VLAN 1 so that it's like a management. So we use our VLAN 1 as a default to manage devices, and that can actually be completely untagged. So no different to buying an unmanaged switch. You'll take them out of the box, you'll plug them in using cables, whether it's fiber cables or whether it's RJ45 cables, and they'll be able to get DHCP if you've got a DHCP server, and you'll have assignments that you can have. All the communication will run between the switches on those VLANs. So what you'd have to do is have multiple VLANs to start separating and segmenting our network. Now what we've done here is we've got 4 VLANs, right? So you've got VLAN 1, VLAN 10, VLAN 20, and VLAN 30. That's 4 VLANs that we're going to use. We want the accounting team to be able to talk to printers and servers on VLAN 20, and we also want the support team at VLAN 30 to talk to VLAN 20 as well. But what we don't want to do is have VLAN 10 and VLAN 30 to talk to each other. So what that means is the information on the switch is being trunked across VLAN 1, so all that communication of the switch is being trunked across, and VLAN 10, 20, and 30 is tagged. So what happens is there's information on the tag that tells the switch what VLAN it's designed for. And we'll have a look at that on the next slide. So this is a typical packet or frame on the network. So you have destination, source, type, data itself, and just a checksum to make sure that the information is correct. Now what we do with VLAN tags is we want to insert a different type. Okay, so we take our VLAN tag, we insert that into the frame. Now what happens is the switch is able to see the VLAN tag. So let's say that's a VLAN tag of 10. Any device, like such as a switch or router that understands the 802.1q protocol, will see that tag first. It will decide which VLAN it's for. If it's not for itself, it will send it on to the next device. If it is for itself, it will remove that tag and then inspect the frame without the tag on it, because it's for itself. And that's how VLAN tags work. You have to have a tag device to understand VLAN tagging. Now, the problem comes from when you have a device such as an unmanaged switch which doesn't understand VLAN tags. That's why you need to make sure if you're going to use VLAN tags on your network, any devices such as switches or small switches, they kind of need to be smart switches so that it can understand the devices. If an untagged frame was to reach a device such as an unmanaged switch, that would be fine. But if a tagged frame reaches an unmanaged switch, likelihood is that it can get dropped. Now there are some unmanaged switches which are able to forward frames without inspecting VLAN tags but are aware of them. So it might not necessarily drop them all the time, but you do have to be very careful. My advice is, if you're unsure, make sure that you're using a switch such as a smart switch or a managed switch which understands the 802.1q protocol. So when we're talking about VLANs, naturally we have to start at the gateway. So really what you're going to do is you need a business grade router. That's what we're really talking about here. So let's have a look at one of those. So we have a DSR 1000 series router and DSR 250. What I've done on here is just showing you a screenshot of how I've created the VLAN tags. Now, what you'll notice is that the IP address and subnet mask is the network. So those are our virtual networks. So you can see I've got a default IP of 192.168.99.1 as VLAN 1, and that's a standard /24. And then I've inserted multiple different VLANs. So VLAN 20 was going to work at a completely different subnet range. Now, let's say, for example, I wanted a guest network. I wanted people to come into my business, and I want them to use the internet, but I don't want them to have any access to any devices such as my servers or my printers or anything like that. So what I would do is I would use VLAN 20 as an example for my guests. Maybe I would use VLAN 30 for my accounting team, maybe VLAN 40 for my art team or art department. And that's how you break it down. So what they'd actually have is its own DHCP server. So they would be assigned DHCP from a different subnet that can only communicate within that subnet and nowhere else. Now they can still use the internet, they can still get out because it has that connection out to the gateway. Now once I've made my VLANs, what I then have to do is make sure that my trunk from my gateway to my switches understand the VLAN memberships. So I'm going to use port 1. So this is a router which has 4 ports. Port 1, I'm going to turn it into what is called a trunk. And what a trunk means is it's using one cable to pass multiple VLANs across it. So multiple traffic, multiple subnets are actually passing through this one cable, and that's going to go to a switch. And here you can see I've used port 1, and that's going to have 1, 20, 30, 40, and 10 as well. Okay, so all of the VLANs that I've got listed can be put onto there. I can also use my other ports as well, so port 2, 3, or 4. I can have direct access. So I've got access mode set there for VLAN 1, but I can change that to say 20 or 30, so I can plug directly into the router with a PC, and I would then be assigned a DHCP from the respective VLAN. Now, it's really important, again, that the devices you use understands the 802.1q protocol, because if you use a router that can't do the VLANs, then you won't be able to do them for anything like DHCP assignments unless you start using things like layer 3 switches.
So very, very important to read to make sure you get the right router. As you said, Craig, it's the gateway to the network, isn't it? So
It is. I mean, it doesn't have to be all the same vendor. You can certainly use different vendors and mix and match switches or mix and match the gateways. You just need to make sure that the standard is there.
Yes. Yes. So even if you've got a different company's router, that doesn't mean you can't buy D-Link switches.
Exactly.
So now moving on.
So I'm going to show some switch configuration here, Alan. And for this example, I've used one of our DGS 1510s, which is a standard smart switch. This is actually a smart switch plus, and that will come with some ports for stacking and 10 gig aggregation on the SFP side. But what we're actually going to do here, because it's a router, and the router, general routers don't have SFP ports and things like that. For most of them, there are some that exist, but naturally the thing to do is to use an RJ45, just an Ethernet cable, and then plug that into switch, and that's your 1 gigabit connection going back to the router. So here I'm going to use port 1. That's what we're going to be looking at, and I'm going to select port 1 as my trunk. Now remember, on my router, what I've done is I've set port 1 on my router to be my trunk, and I've assigned all of those VLANs to that port. So now I have to do the same thing to port 1 on my switch as well. So let's have a look at how I've done that. So it's a layer 2 feature. That's a really important thing to understand. VLANs work at layer 2. And that's really because they use the MAC address to assign devices, and it's a layer 2 device. You don't need a layer 3 switch to do VLANs. So on here, I go to my layer 2 features in my menu, and then I go to the 802.1q protocol, and then it comes up my memberships. So in the VID list, all I've done there, so out of the box, you'd have VID number 1, you'd have a VLAN of default name, and everything is untagged, okay? All the ports there, completely untagged. So using that VID list, I've just inserted 10, 20, 30, and 40, and then clicked apply. and that's allowed me to add my VLAN memberships. So what I'm saying is that this switch understands that there are 5 VLANs available to it that it can use and understand, and those are the numbers that those frames are going to use. Okay, it's not tied to anything in terms of IP addressing at this point, and that's mainly because I've used the same default address of VLAN 1 to do all of my connections themselves. So let's say, for example, it's working on my 192.168.99.1 network, as we saw in the previous slides. And if I was just to plug anything into it at the moment, it would just pick up an IP address on that network. So what I have to do now is I have to define the ports. So I need to make sure that my ports are set up so that it understands what the trunk is and what the VLAN is. So the next step, if you can move it along, Alan, is we'll see the actual VLAN interface. So these are the interfaces that you would use. So in this example, because it's a stacked unit, I'm select unit stack 2, and I want to select trunk. So what I do is I'd edit that port. So here I've got port 2, number 1. So port 1 is going to be my checkbox, and then I'd click edit. Now when I click edit, this is what comes up. So for VLAN mode, I've got a few different types that I can choose. There are 3 types. There's hybrid mode, there's trunk, and there's access. And they all do very different things. Now, if I use trunk, let's say, for example, I use trunk on port 1. What that will do is it will make sure that every VLAN that is aware of is able to pass along that trunk port. Okay, so it doesn't care about security from that perspective. It's just a trunk port, and that goes back to my gateway, and it will pass any kind of VLAN tagged frame. It'll have a native ID still, so the native would be the untagged, which is VID1, but any other tag port is all going to pass. If I use the hybrid mode means that I'm passing tagged and untagged traffic, but I have to define the tags that I want to pass as well. Now, I prefer to use hybrid mode when I set things up on switch, because it allows me to look at a switch and know exactly what VLANs are available to it. And it also means that I can implement some security. So let's say, for example, this is an edge device, and I have 5 VLANs at my core and my distribution. Now I get to the edge, and this device might, for example, be a school's 6th form block. Okay, now the 6th form block will have a very different kind of network. It might have things for the kids, it might have a guest network, things like that. Maybe it doesn't need all 5 of those VLANs, maybe it just needs 3 of them. So if I use a hybrid mode, what I can then do is just say, well, I just want those 3 VLANs to be aware. So in my memberships, I just keep those 3 VLANs, and then I set to hybrid mode, and then I would just add those 3 LANs as a different check. Now, access mode is something very, very important. What you need to understand is a PC device or a laptop or something like that doesn't know what a VLAN tag is for the most part. Okay, it's not on the NIC cards. So you can buy some NIC cards, and you can have some advanced NIC cards that are made on laptops and things like that where you can add a VLAN tag, but that's an advanced feature, and most people don't have that ability. So what you have to do is make sure that when you plug into a port, you're choosing which VLAN it assigns from so that it can get DHCP and it can get communication. Because what happens is the switch is going to understand that packet, and it's going to add that VLAN tag on that frame for you and then move it along the network. That's why the other devices need to understand what VLAN tags are, because it's going to inspect that frame, take it off, find it out who it's for, and then it might need to append the frame again and move it on. So it's kind of like every step you go through, every route you go through, it needs to understand those frames. So once you've understood the VLANs, you've set up your memberships, you've set up your ports to use VLANs, what you also have to do, or you don't have to do, but is advised to do, is some ACL rules. What that means is, especially if you're using private VLANs, you can start managing the devices on the network so that they can talk to other VLANs and maybe not talk to other VLANs as well. So an ACL rule is basically an access control list. So here I've got an access control, and what I've done is I've said this device is a network. So I've selected the IP and I've given it its mask, and it's a 192.168.99.0. So anything from that source going to the destination 192.168.30.100, so let's say that that device would be a printer, is allowed. So I've clicked permit. Now, for everything else, I could create another rule, and then that rule would be deny. So for anything else not going to that printer, I could deny anything going to a different VLAN. So that's what I can do. I can start allowing different VLANs to talk to each other, so that maybe I can have a shared printer or shared resources between the switch. That switch might have multiple VLANs. It might be doing multiple different groups of people, maybe guests, but they can still access some shared resources as well. It also means that you can have, as an admin, you could have rights for your IP address and tie things into your MAC address using some other parts of the switch, so you can lock things down to just your device that's allowed to go for different VLANs at the same time, so you can be aware of all different devices as a management platform for yourself, but everybody else has their communication blocked if they're trying to go to other different services.
Ooh.
I think the hardest part about VLANs is just making sure to understand how it flows and how the ports need to be configured so that you're not forgetting any VLANs. It's very simple, very easy to forget sometimes that as it links between switch to switch, you have to make sure you do your trunk ports correctly. Okay. Now, because they're an access point, for example, that would have to be a trunk port, because what we've done is we've made sure that we're passing multiple VLANs, so that needs to be a trunk port, because as you know, and as I've explained, you must have a trunk port or hybrid trunk in order to pass VLANs effectively. Okay, so anyone that was with us last week will have seen this diagram. We're going to expand on it now by making our VLAN implementation. So here I've got 4 VLANs that I'm implementing. I've got my managed network on a 1.0, so 192.168.1.0. I've got 20.1, 30.1, 40.1, 50.1 as a network. Okay, that's what we can use. Those are available to us. So as I've said, we need to make sure they're on our network here. So I put in 1, 20, 30, and 40. Now you'll notice I've forgotten 50. So 50 will not work on that gateway because I haven't selected it at any point. Okay, so even though I've set it up correctly, I can put it on the router, I can put it 192.168.50 on the router, but because I haven't assigned the actual port itself, it's not going to work on 50.
Right.
Won't understand it, won't reach the next switches. Okay. So what I need to do is on port 1 on my gateway, I've put 1, 20, 30, and 40.
Oh,
But maybe on a switch.
Craig, you've cut out. Craig, are you still there?
Access of 30. So when they plug into the switch, they instantly get DHCP from that VLAN 30 and that VLAN 30 communication. Okay.
Craig, I think we lost you for about a minute back then.
Oh, really? Okay. Okay. Yeah. Shall I go back a little bit?
Yeah. Can we? I think go back to where we were talking about hybrid. One at this stage here where my mouse is on the screen, so hybrid 120/30 at this stage. I think after that you we lost your volume for a little bit then.
No problem at all. Okay, so I was mentioning that I've introduced the 50 network onto the rest of my devices.
That's where we were.
And that will go through the rest of my network. So it won't go to my gateway because it's on that device, not the rest of my network. So that's where it goes into that private VLAN state. Now, access 30 is what I've assigned to my switches and to my scanning devices, my multi-platform devices and servers and things like that. Now, because those devices don't understand VLANs, they have to be tagged as an access mode and then plugged into the switch. So let's say, for example, I plug a server into port 6, it would be access mode for VLAN 30, and that's how it gets connectivity onto that network, okay? Now, I need to then put it to my distribution switches as well. So I know that I have to have my VLANs on my core switch, and I have to replicate those on my distribution if I want to make sure the rest of my 3 different networks areas here, so maybe these are floors in a big building, and that's how I'm going to trunk them. So there's going to be trunk to trunk. All the switches are going to have a trunk port. You've got 2 cables going there to 2 different switches, and they're stacked. That's absolutely fine because they'll have port channels, and the port channels can be used with hybrid mode or trunk ports as well. Okay. So let's break down now into the rest of our network. So I've got 1, 20, and 30 that I want to use with my PCs. Okay. PCs don't need to have access to 40 and 50. So I've left those out on the switch intentionally. Okay. Only 3 VLANs are going to be available. It always has to have that first one because that's our management port. And if you don't have that management port, you're not going to get connectivity back to your core. But the 20 and 30 can be used however you want to. So in this case, I've assigned an access mode on the PCs to have 20. So they're going to plug on to VLAN 20. That's going to go through to my distribution, back to my core, right up to my gateway and out to the internet. They're still going to have that connectivity. Now, a PC that's on the left and a PC that's on the right are going to be able to talk to each other still as well because they're on the same VLAN network.
Right.
So now I've got my ports for my phones. Now my phones might have a PoE switch. They don't really need to be connected to the rest of the network really because what's the point? It's just a phone. It doesn't have to have any kind of connectivity. It's a PoE phone. Yeah. So I've given them an access of 40. You'll notice that I still have a hybrid default 1 there. The 1 is our access point for our management, and then I've just added that second VLAN. Now let's look at our cameras. So I've put the default of 1 and 50 this time, and 50 is going to be used for my cameras and also my NVRs as well. We have to make sure it's access mode at 50 for any of the devices, and then the trunk ports between the switches and switches will be 1 and 50.
Makes sense.
Okay, now I think there's one last step, which will be our PC. Yeah, our PC that's plugged into our core. So that's going to be access 50 as well. Now, what you've seen, what I've done is I've got cameras and NVRs that are available from all of the devices at the core level, but can't get out to the internet. You see? Can't get out to the internet, so they can't be compromised from an outside source. They'd have to be compromised inside if anything was to go wrong like that. So I've managed to create this secure network of layers and parsing using the same devices, segmenting my network, being able to use the same switch for different devices, different VLANs, but still maintain security. And because it's all broadcast information, the broadcasts don't go from one LAN to another. So the optimized network, the actual frames themselves, they're not overlapping. So what happens is people generally have these old flat networks. We call them flat networks when you don't use VLANs like this. And a flat network basically means that all of that broadcast traffic is available. All these devices are pingable, and they're all in one network that all talks to each other, and everybody's talking at the same time. You start breaking that traffic down, you start making it so that you can get a more optimized network, flows better, you're not overlapping with other communications, and that's how you can make a more secure network, but more functioning, improved, optimized network too. So hopefully that has shown you what you can do with VLANs.
It's almost like you planned it, Craig, to be perfectly honest there. How well that worked out with the Access 50. Almost like you planned it. Yeah. And I take it that Access 50, that would be like a standalone computer that could be used to monitor the NVRs and the cameras from a station.
Correct. So
like a
absolutely, yes.
Security aspect.
Yes. So for example, we got our MVRs there, those D-Link MVRs. You would install a live viewer and maybe a playback manager as well onto that Access 50 device, so that you can actually access the MVRs from your core. And because they're all, core's all tied to the distribution side to the edge, it's all manageable, it's all viewable on that one device.